Hi guys, time for some more math. This particular intro is kind of a tough one, so I've decided to approach it the way that makes sense in my brain to help you guys get it. So follow along with me. We're going to do this math first in a different strategy, and we're going to use those answers to help us fill in what they're trying to show us, okay? I'm going to make sure that you have the answers, so don't panic. I'm not going to be asking you to fill in anything like this again, so relax. Let's go ahead and talk our way through it, because even for me, this was a little bit hard to understand what they were having us look at. I understand the underlying theory behind it, but it's difficult for me to be able to explain that to you when you're there and I'm here. So we're going to change things up a little bit so that you can get what you need from this one, okay? So let's check out our first problem. Aiko lives 4/5 of a mile from school. Bianca lives 3/10 of a mile from school. How much farther from school does Aiko live than Bianca? Okay, so we're going to start with the 4/5, and we're going to be subtracting 3/10. Now, we can't do a subtraction problem with these the way that they are because they don't have a common denominator. So we have several strategies to find one, right? We can take these numbers and multiply them together. We can see if I can change one number into another, or we can do a least common multiple list, okay? I'm going to go ahead and take a look, because 5 and 10 are easy to work with. I can turn a 5 into a 10. So I'm going to take this 4/5, and I'm going to create an equivalent fraction, right? I'm going to change it into tenths, and we've done this lots of times before. So what did I do to 5 to make it into a 10? I multiplied by 2. If I do it to the bottom, I have to do it to the top. 4/5 and 8/10 are equivalent fractions. So instead of using 4/5, I'm going to come up here and I'm going to replace it with 8/10. When I do that, we can do the math. 8/10 minus 3/10, the denominator stays the same. 8 minus 3 is 5. Now we're not quite done with this yet because it's not simplified. What factor or number do these have in common? Well, they both could be divided by 5, right? If I do that, I end up with 5 divided by 5, which is 1, and 10 divided by 5, which is 2. Okay? We've now solved the problem. We know that Aiko lives 1/2 a mile farther from school than her friend, because we set up the problem, we found an equivalent fraction, and then we simplified. Now, let's get into what they want you to look at in the problem, okay? So they want us to model the fraction. So what they've done is taken the distance to school, right? They're saying, okay, here's home, here's school. Let's draw some fraction boxes. So because Aiko was 4/5 of a mile, they split that into fifths, okay? And then Bianca was 3/10 of a mile. So they're taking the same distance, and this time they're splitting it up into tenths. Okay, so if I have to show Aiko's, it is 4/5. You have this actually done on your paper for you. It's just me trying to recreate it on the board. So they're showing her 4/5 like this. So this is Aiko's. So that would be this amount right here, right? 4 out of 5, 4/5. These are all fifths, 1/5. Let me clean that out so you can see it better. Seemed like a good idea to color it in, and then it wasn't. All right, so back to this part. 4/5 means 4 parts, right? This is 1/5, this is 1/5, this is 1/5, and this is 1/5. Now Bianca's is in tenths, right? Same amount split into tenths. So this is 1/10, 1/10, and 1/10, okay? I just drew what they had for you here. It says find which fraction tiles will fill the area of the dotted box. They ask us if we can use 1/3 tiles. Now, immediately my brain starts thinking, is 3 going to work with these numbers? I'm thinking about common factors of 5 and 10. Is there a way that 3 would work that way? If I were to list multiples, I would find out that no, that doesn't work because 3 is not a common multiple of these numbers. So for the first part, you can say no, okay, because that's not going to work. Now, the second part says, do half tiles work? I want you to look back at what we figured out when we did the problem ourselves. Here's our answer. We have an answer that ends in halves. So they want to know how many half tiles would fill the dotted box, okay? Now the dotted box is this part right here. And it's hard without being able to manipulate those and move them around to see how many is going to fit. So what they're asking us to think about is how many half tiles would fit in this part? Well, this is really the same thing as 7/10. So I'm thinking in my head, is this going to work? Well, I know it's going to work because we come up with a half up here. But the question is, how many of those would it take? All right. So what I'm really trying to do is take this fraction, and let's see if this is going to work. Right? This is the same thing as 4/5. I'm trying to take that, and I'm trying to see how many halves will fit into that. Okay? So I'm trying to make, oh, that's not going to work for that part of it. When in doubt, check the book, kids. I know that halves will work without having to teach you division of fractions, which you're not quite ready for yet. We're going to consult the book. Okay, so what they're trying to tell us is this piece minus this piece. How much is going to be left of this? They're telling me that 1/2 tile will fill the box. So the first line was no, because 1/3 tiles won't work. Half tiles do work, yes. How many half tiles filled the box? According to my book, it is 1, which I think I see more than that, but we're going to go with what it says for now. So down here at the next part, it says since 1/2 fills the area of the dotted box, 4/5 minus 3/10, which is just what we did up here, is equal to 1/2. So right here, you're going to take your 1/2 and also write it down because we figured it out. She lives 1/2 mile further than her friend. Okay? Let's go ahead and take a look at this next part. I know I keep wandering on and off. I'm going to do this one the same way, where we do our regular math first and then we try and figure out their fraction tiles. This is not going to be the most important thing, but we can do it. Now, the next one says 3/4 minus 1/6. We can't subtract these guys because they don't have a common denominator. The last time we were able to turn one number into another, but I can't turn a 4 into a 6. I'm going to use least common multiple to find a common denominator. Let's do multiples of 4. That would be 4, 8, 12, 16, and 20. Let's list some multiples for 6. 6, 12, 18, 24, 30. What is the least or smallest multiple that these numbers have in common? Well, they both have a 12. So guess what we're going to do? Take these guys and turn them into 12ths. So I'm going to start with 3/4 and I'm going to create an equivalent fraction. You guys have been doing this for a while now. What am I going to do to the 4 to make it a 12? It's times 3. Do it to the bottom, you have to do it to the top. 3 times 3 is 9. This is the new fraction, the new equivalent fraction I just made by turning it into 12ths. This is not new math. I'm going to go ahead and write it right here, 9/12. Now, I need to do the same thing to the 1/6, right? I am going to turn it into 12ths. So how many 6s does it take to make 12? Times 2. Times 2. So 1 times 2 is 2. This is my new equivalent fraction for 1/6. So 3/4 is now 9/12. 1/6 is now 2/12. Now that I have found a common denominator, I can go ahead and subtract. The denominator stays the same. 9 minus 2 is 7. And I am finished because 7 is a prime number and I cannot simplify it or reduce it anymore. Let's go to what they're trying to show us here. They've drawn it out. They've done 3/4. So 1/4, 1/4, 1/4. And they have 1/6. These are not quite drawn to scale, which makes it a little bit confusing. Okay, this one is 1/6. So they've taken the original amounts, because remember this is 3/4. But you can read that. Let's try that again. Okay, this is 3/4. This is 1/6. They want to know what belongs in here. This is the unknown. Now we did this math. We have it right here. We took the math. We created equivalent fractions. We subtracted. Try 1/3 tiles. Do they fill the dotted box? Well, let's check our book again. As I suspected, 1/3 tiles will not fit the box because 3 is not a factor of both of these numbers. So right here where it says try 1/3 tiles, did they fill the dotted box? No, they do not. Try 1/12 tiles. Do they fill the box? Now, look at what we ended up with up here. We ended up with an answer in 12ths. So we should be able to say yes for that part. How many 1/12 tiles dotted the box? Look right here. How many 1/12 tiles? There's 7 of them. So that's going to go there. So 7/12 goes in this blank. 3/4 minus 1/6, just like we did, is 7/12. That's going to go right there and also right there. If you get tangled up with this, it's okay to send me a message. It's okay to skip it with a note so that I can talk to you about it later. I know that this one is tough. If we can stick with the strategies that we know to help us figure out new ones, we can do this. All right? Let's do a couple more problems where it's a little bit more straightforward, okay? Let's go get in here. Let's get on to page 2. We have number 3 is the first one on page 2. Okay, we're going to do number 3 together. It is 2/3 minus 1/6. Okay, we can't just subtract because they don't have a common denominator. We have practiced changing one number into another. We have practiced using least common multiple. The other one we have not practiced yet is just multiplying them together. That makes you have to simplify in the end. So I really think your 2 best choices are seeing if you can turn one number into the other or to do least common multiple. In this case, right away, I know that I can multiply 3 by 2 to make 6. So what I'm going to go ahead and do is take this 2/3 and I'm going to turn it into 6 because I know I can because it's easy. So 3 times 2 is 6. 2 times 2 is 4. So we've made an equivalent fraction. So instead of using this one, we're going to use this one because now it's in 6ths. So 4/6 minus 1/6 is equal to 3/6. Well, we always want to ask ourselves, are we finished with this problem? We might need to simplify. These numbers both have a factor in common. They can both be divided by 3. So if we do that, 3 divided by 3 is 1, 6 divided by 3 is 2. This is the answer that we want. We have found a common denominator, we've created an equivalent fraction, we've gone ahead and subtracted, and we've also simplified. Let's do another one. 5/8 minus 1/4. This is number 4. So 5/8 minus 1/4. Okay, we practiced turning one number into another up here. Let's practice least common multiple down here with these guys. So let's list some multiples of 8. So 8, 16, 24, 32. Let's also list some multiples of 4. 4, 8, 12, 16, 20. We are looking for the least or smallest common multiple that both of these numbers share. Well, look at that. They both have an 8. So we want to change these into 8s. Luckily, 5/8 is already done. So all we're going to have to do is change 1/4 into 8s. So what did we do to 4 to make 8? Multiply by 2. If you do it to the bottom, you do it to the top. 1 times 2 is 2. So instead of using this 1/4, we're going to use this 8 so we can actually do the math. So we're going to go back to our original problem, which was 5/8 minus, we're going to use our new 8s, minus 2/8. So the 8 stays the same because we're keeping that common denominator, and 5/8 minus 2/8 is 3/8. This time we know we're finished because 3 is a prime number and we can't simplify. So that should handle that. I think you guys should be okay for the rest of this. If you find it's much easier to do it this way without the models, which I certainly do, I think that you should probably work on this strategy. If you need help with things or if it's frustrating you, take a step away, take a deep breath. If the whole tile and the drawing things doesn't make sense, don't do it that way. Do it this way. Do it a way that works for me, okay? The reason they show you the strategies is to try and help explain it, but every now and then there's one in there that just doesn't seem like it clicks in our heads. And like I said, I'll be honest, this one was hard for me to understand what they were trying to show you without giving you too much extra math. So stick with what we know. Do what we know how to do. That's the easiest way to get through it. You can do it, guys. We'll see you soon.